Sometimes it lasts like 10 years or more. So, however, that doesn't mean that the customer is not experiencing more, expecting more from the company or the product. And now the consumer mindset for specifically for electronic products nowadays is to expect regular product upgrades, to expect more innovation and cutting edge features. So this perspective really marks a transformation in the business customer relationship that we can take advantage. And now we have an opportunity to know our clients better and to give them more personalized service and to have a continuous relationship with them. Before the old model that still continues is like you buy an appliance, a white good appliance, and then probably between 1 and 10 years the customer relationship is completely lost because the product works well. So now what we aim is to have a continuous relationship with the customer. Okay, so but despite technological advances, as I was saying previously, um, there are still very few smart applications for white good appliances. So most of the smart home applications goes from voice assistants, devices, or the vacuum cleaners, but not too many applications for white goods. Uh, I mean, solutions could be simple features such as providing recommendations on how to use the product in an app, and or also more complex for like AI models for energy optimization or automatized decision making. I mean, there are still applications. Lots of companies are working on that, but we can also take into account the cost of this appliance. So uh, if you put cameras, for instance, in the refrigerators, then how many cameras are you going to put there? That increases the cost. Also, processing is not very easy to process in terms of data uh, images. You need to also have all the sensors. For instance, you want to process the video on real time every frame, but you can also put some sensors, some weight sensors, in order to detect when a customer remove some item from the refrigerator, to take a photo or to take a sample video and analyze that. So, but what I mean is that you need lots of infrastructure. Then that elevates the cost of the product. So um, you have to take that into account in terms of business and industry, which is very different from research and from doing very cool stuff. You need to think about this as well, and if it makes sense for the business. For Mabe, it makes sense, and it makes sense to start investing efforts into doing this, even though the big percentage of products sold by Mabe um, is not the premium brand, but is for the mass market. So basically, we should ask ourselves, like, in what way could the company increase user value when a fridge or a washing machine are being controlled to the internet? So if I'm a customer and I buy this, I need to know that I will have something else, and also because the every device that is connected to your internet then it's taking data, um, and then sometimes customers just disconnect the devices because maybe they don't perceive enough value in the solution. So for us in Mabe, I think it's of extreme importance. First, I mean, working on several projects. But one of the most important is how to improve maintenance capabilities or reduce malfunctioning. And I'm going to tell you why it's important. So first of all, I mean, we could reduce business costs associated with repairs in warranty for the company, improving customer experience, enhance sustainability, post-purchase maintenance services, and we could improve future device designs. So with only one topic, we can have several outcomes. So what if the detection of potential problems? What if we detect potential problems before they happen? Then we are able, if we are able to infer a probability of a potential problem before it happens, then a customer avoids any machine downtime, which can be a huge inconvenience, especially in appliances such as refrigerators, which are connected all the time. So if it breaks, you just, you or the family gets into a big problem because, it's kind of an emergency. And for us, for the company, an early diagnosis can prevent a more costly repair or replacement. So this is a win-win situation for the client, which is if it's out of warranty, then he has to pay a lot, and for the company, if it's in warranty. Also, the customer saves time and effort by not having to phone the call center. Customers do not enjoy, in general, call the call center. So with predictive maintenance, we could potentially contact the client before it experiences a malfunction, and its appliance, and to make its journey service more satisfying. From an appliance manufacturer perspective, this also reduces call center costs, so making it a win-win opportunity. Okay, there is another point, which is there is less time spent waiting around for engineers. So by monitoring the performance of possible errors, we can optimize visits or engineer visits to fix the problem. So the optimal situation is that the engineer fixes the problem on the first visit, right? Sometimes it happens that the engineer goes, he doesn't know what's the problem, he doesn't have a clue of what's the problem. He examines the device, and then it goes on a second time to put the broken piece, and it gets resolved in on average, 2 visits, right? So we would like to have it only in one visit, knowing previously what's the issue. And you can also have customer loyalty. So if the customer knows that there is high-end technology built in the appliances, then the customer trusts the appliance, and he knows it won't break down unexpectedly. So you get more loyalty to the brand as well. And there is a very important factor as well, which is we are more environmentally friendly. So the ability to repair more machines as opposed to replace them is very significant due to the high carbon emissions associated with manufacturing, right? So sustainability is a topic that is important for consumers nowadays, and knowing that technology has been built into an appliance to make it last longer is very good for the customer and very good selling point. Okay, and with this also, we can have another models, or not only models, but because most of the malfunctions, you can have some variation in energy. For instance, when a fridge compressor is not working properly, then it could cause to appliance to function with more or to get more electricity, or increases the voltage, right? So maybe you're not noticing this kind of symptoms, but you will notice it on the bill. So with predictive maintenance, we can monitor this, um, and checking if that situation is happening, then visit the client and fix the problem, and the client will be happy because he will pay less for energy. So, what are we doing in this field? I will tell you very briefly what we are doing. It's an ongoing process, and I'm still not able to uh, show results. I'm gonna show you what I can in terms of confidentiality, but we have several teams involved in this. We have the product leaders, we have customer service. There is an specific area called IoT, and us, which is about advanced analytics and data science. And we are working very closely to develop the best solutions. At the moment, we have a first POC in washing machines. The objective, as you know, is to model the behavior of connected washing machines to predict if it will have an error at that moment. And also, the most important for future design or for engineers is to know what are the weights of or importance of all the features you use. So at the moment, we are approximately using only 90 cycles with 1% of errors. As you can see, errors are really, really low, which makes difficult for a machine learning perspective to start modeling well um, errors. And we use more than 200 features coming from sensors and others obtained by feature engineering. We're modeling using normally XGBoost and neural networks and some ensembles. But I think we are in the correct path. So for our best model, we have 78% of true positive classification and 98% of true negative classifications in out of sample validation. So if we take into account that we only have very few data, because these products just they're about to get into the market, so the product that we have now, it's just a sample that is working, in just a sample with people within the company. It's a very small sample and very few data. So with that, as you know from working with AI and data science, the better the data and the more data you have, you could improve your models. So we need to obtain more data to generalize much better. That's for sure. The results we have when we analyze the importance of variables makes lots of sense for engineers. So engineers trust the model because they know, and it makes sense what the model is saying about what the importance of variable is. But definitely, this is a work that has to be continuous every often and every, I mean, with a very often, as soon as we get more and more data. So now the teams are creating also the data pipeline and the data loaders to move the project to a second phase to work in real time. So we have two different separate teams. One is working also with all these data pipeline and data loaders. Once we know and once we trust the model, then we can implement it in production more easily. So this is it. I hope you like it. And I'm open to any questions you have. Thank you so much.
Thank you, Gerardo. We appreciate that. Oh, I'm not sharing my. We have a few questions from the audience. All right. Question one: how do you determine the hardware needed to run the models in each different appliance? So the differentiation between a refrigerator and a stove.
Yeah. So that's a great question. So at the moment, the first line that is going to the market, all the processing is done outside. So it's not done within the appliance. Yeah. So it's done on the cloud, on the servers that we have, taking into account that for our real-time implementation where we can communicate with the device on real time, have a response on real time, and maybe change something on the device on real time. We are thinking more in the long term, maybe in the second or the third generation. So yeah, that's a good question for when we implement that on the appliance, and it might be a mixture. Maybe you can run the model or some models which are not very heavy in terms of processing capabilities. You can run it in the hardware, in the appliance, and maybe others you can take it to the cloud and then go back with an answer.
Gotcha. And then the follow-up, it looks like, to that would be, how do you determine the right model architecture to make sure that it's performing?
Well, I think you determine that by checking your matrix or your scores. So you have different scores in machine learning, and depending on what you try to model, then you have your matrix score that you want to measure. So even if it's a pure logistic regression or a deep neural network, it might happen that you might end up using a logistic regression because what what your score, what you put as a score, you have a better score doing just logistic regression. So I think it's just a matter of what score you're using and what you want to optimize, and then that's how we select the model. And also, I mean, also you have to take into account the time that the models uh, needs to give you an output, right? So if you need to have an answer very quickly, maybe that's something that you also have to take into account before selecting a model.
Gotcha. Thank you very much. And then there was a question on like fully autonomous kitchen appliances being available, ones that can actually tell you in your refrigerator what's to eat. So like, how do you go from this first, I guess the question is asking, how do you go from this first initial output into something that can have a camera in your refrigerator and say, you have these 7 ingredients, why don't you make this dinner tonight, right? How do you take it from its earliest stage into something more advanced, I guess, is the question.
Yeah, I think that has to go with how the company wants to drive the business model. So recently, I just went to Amazon Go in Seattle, um, and it's just amazing how many sensors and how many cameras they have just on the roof, just to monitor um, like what was the item that you're taking. So it's like huge the amount of sensors that they have. So I guess that's resolves the question as well. I mean, there's one important issue also in this kind of intelligent applications, which is not only how to use cameras and how to analyze cameras, but also how you or what's the placement of the cameras and how you put the cameras, and then it is so where to put the cameras, and also if you put the cameras there, you need to also calibrate all the cameras inside, which is really a big problem. Um, so it's a lot takes a lot of research, and takes a lot of hardware, a lot of investment. So I guess when the time comes that we can see all the fridge with very smart features inside, I think we will also need the technology and the prices to go down in order for the people to buy these kind of products, because these products are very expensive nowadays. Sorry, Kyle, I can't hear you.
Right, that's my fault. Yeah. How do you pass the good timing on an investment question? How do you pass back? The question is, how do you pass back the cost on cloud computing to a customer? So if you're receiving all of this data back from a customer and it goes up into the cloud, and then you're doing all this computation on it, whether it's labeling or machine learning, are you passing that back to the cost, or is that just going into an R&D budget? It looks like is the question.
Yeah, that goes to an R&D budget.
Okay. And then will you ever, I guess the follow-up here is, will you ever pass on those costs if to a customer, like on a subscription or something of that? Is that a thought of a business model, or how does that going to work in the future?
That will be tricky, because so it's not only this, but also the quality of the Wi-Fi. So normally these appliances are connected to Wi-Fi. So it might happen that the refrigerator or the washing machine is in a room, and in that room the Wi-Fi signal is very, very low. So you have, or as a company, we're also taking into consideration that maybe the customer will have to put or have to install another router to have more connection in the house. Eventually, the tendency is that most of us now we're trying that our houses have connectivity everywhere. But if that's not the case, then we as a company are also thinking about how to help the customer, maybe subsidizing some part of of another router, so he's able to connect the appliance to the network, because that's what we want. So we want the customer to connect to the network. So we are trying to help into that. So now, if we add the cost of data in the cloud, maybe that's not going to be I don't know, that's not going to be very that's not going to make a very happy client, maybe.
Gotcha. Question from our own team here at Clarify. Jeff Green, associate out of the public sector, wants to know, how much improvement in efficiency are you getting, and how do you estimate the dollar savings, or what are the dollar savings, if you could provide that information back?
Yes. We're actually creating the business model at the moment, and we have different inputs that we're going to take. But one of those is how do you call this score for client satisfaction, NPS? Well, there is this score for client satisfaction, and we have an estimate of how much uh, how much 1 point of that score costs to the company. So if we are able to improve it, then then we have now an associated cost with regard to customer satisfaction. And we have then others that we are investigating as well.
Gotcha. Personal question from me. There are no more outstanding questions outside, but how do you guys determine the level of resources that you're going to put into computer vision over, let's say, the next year to 3 years? 5 years is too long. So, next year you said you wanted to start spending more money or investing more into computer vision. How did you know that you wanted to do that? And then how do you know that you're going to, get the output that you're looking for?
Okay, so I guess it's about, as a business, can you reduce costs by using a solution using computer vision, or not only cost but risk associated with it. So mostly in manufacturers, you can use computer vision for quality inspection, definitely. And also you can use computer vision for processes where there are risk involved when people is there. So I guess it's just a matter of you can use computer vision in different parts, like either reducing costs associated with human resource, or reducing costs to the company, or improving a process. So if you can reduce the error of checking just manually or with a human all these parts, and you can reduce that error by doing it automatically, then it will bring you a cost saving.
Okay. Actually, we got 2 more questions, and we do have the time, so I'm going to ask them. Eduardo Torres asks, this is not strictly related to predictive maintenance, but are you using your data for predicting demand trends as well?
Okay. So yeah, I don't know what he meant, not related to predictive maintenance. So with our model, we can, as we model when or we have a probability when it's going to break, then we can have a strategy for making this maintenance to the product, to the IoT product, and we can predict as well in I don't know, a week or 2 week times, if the probability is going up, then it might say that the appliance needs a maintenance. So I don't know what you meant, Eduardo, with not strictly related to predictive maintenance. Yeah, and using your data for predicting demand trends. We are using data for definitely where we have a project for demand forecast, but it's not the data that we have from the IoT products or this particular project.
There was a second question follow-up from Eduardo about sensors and using them to measure how much is the kitchen space used within a home. I think that's, and he followed up with, demand trends by region, type of kitchen, house versus apartment, things like that.
Yeah, we can. Yes, all the maybe not as you are saying that, but definitely the dimensions of the but the thing is that this is another project. This is another project, and in another projects we know that the dimensions and the weight and all these kind of specifications, it's very, very, very important for the customer to make a decision on buying a product. So I don't know if that answers your question, but yeah, we don't have sensors that measure that in the home space.
Okay.
We can infer that for purchases, from purchases.
Perfect. How do you, another question, how do you collect user feedback?
Yeah, there's a special area in Mabe called customer service, and in Mexico it's called Servicio Mabe or Mabe service, and they have their strategies to collect all this data.
Okay. All right. I think that's it. We're about 5 minutes early. If anybody else has any other questions, pop them in there. I'll give it another 30 seconds. If not, I'll just do some quick updates. Again, I just wanted to say thank you to Gerardo Mendoza from Mabe. Again, he's the head of data science and analytics. His time today was about error prediction and preventative maintenance. The last thing is we will be sending out a link to the recording of this. And after that, I will also be sending out a link to Gerardo's LinkedIn profile. I suggest you all follow him. He has fantastic content, and his team is always doing great things, and you can keep up to date with the Mabe team. I think that's it. Thank you all for attending, and thank you, Gerardo, and have a great day, everyone.
Thank you so much, Kyle. And thanks for the invitation. Bye.
Always a pleasure. Thank you.